All right. So we're ready to go. So if you've got feedback, notes, comments, we're ready to hear them.
All right, great. I believe you all can hear me fine.
Yep.
Great, great. First of all, I think I would say that our professor and I went through all the videos that you people recorded. If I remember correctly, there were around 33 videos. And I'm very impressed to see the content and the concepts that you all have come up with in such a short span of time. So I truly appreciate everyone's effort in doing that. Uh, some of the ideas that I made a note of are like many people came up with this lowered fins idea, which looks like a pretty good, fin design. Seems the most optimized design in terms of fin geometries that are available. Many of you also stated the assumptions very clearly, which I liked. Um, some people made a suggestion of material change from aluminum to copper and so on. So, of course, something pretty much already known in general to the cooling manufacturers. But at one point, it's all about the performance versus the cost and also the availability, the ease of working with the material and things like that, and of course the life, right? Because the oxidation and other things can happen. Some of you also suggested the idea of turbulator inside the tubes, which is pretty interesting as well, like increasing the Reynolds number and having more turbulent flow so that you have better heat transfer and things like that. There were a few, at least I remember, groups which suggested the idea of running the vertical tubes along the tower, which we call it as mast, which was interesting to note. However, the benefits that I saw in doing that was uh, not a lot, and it was not a self-sustained as such a system. So the kilowatt rejection it was delivering was not huge as compared with the amount of heat that we are generating, right? So it was more of a proposal uh, in getting some extra advantage along with having still the primary mode of cooling, which is this cooler. And very, I mean, fairly good idea, completely agree. But I think the complexity, some of that can add to our system can be more uh, probably costly and more maintenance, more risk it can produce rather than delivering the benefits. So, of course, we have to maintain the balance. Many of you suggested good ideas of having a longer travel path using, arranging tubes in a different way or having multiple manifolds, three on the top, three on the bottom, or sideways, having serpentine tubes, things like that. So, which are all pretty good ideas, of course. They will need to be assessed more when somebody wants to adopt those. But at the same time, the space remains the same. So no matter what you do, as long as the you're basically kind of restricted with those uh, area, right? And in that, what better you can do? But good ideas. Many of you, or at least some groups, suggested the idea of having multiple fans, like four fans, arranged in different quadrants, to have a better or even cooling across the whole core of the tubes, which is pretty interesting as well. That is something, of course, relatively doable, I would say, and definitely can add the value. It's just a matter of having little more complexity, running hydraulic fans in four places, and then making sure the power consumption and things like that are not increasing. Many of you suggested the flow control and bypassing the cooler in when it's cold and sending the flow to the cooler when it's hot. You would be maybe surprised to know that we already do that, and we have a plan of so right now, the way we do that is using some thermostats, which is like a wax and a spring element, which extend and retracts as the temperature varies. And we try to divert the flow to the cooler or bypass the cooler based on the temperature. But we have also explored the idea of having an electronic control wherein we read the temperature live and then provide some feedback to actuator, and then that actuator either opens or closes based on the feedback from temperature feedback of the oil. So it was interesting to see that coming up in one of your presentation. The push and pull arrangement, that was kind of interesting as well. Something that at least I have never thought about or seen, that you have one fan on one side of the cooler and one more kind of blowing air on and that is getting sucked in by the other fan. Uh, Probably it definitely, as you presented in your slides, will deliver some extra performance or extra cooling in value. But of course, we have to assess uh, the power demand and consumption by that additional fan and the space requirement of that, right? But good idea. Some people made a suggestion of the pin misalignment so that you disturb the flow across the cooler. And then there was another interesting idea of having some sort of a phase change heat pipe, which is at least like something not known to me, but sounds pretty interesting. I'm not sure about the costs and applicability in our application, but looks like a mm, advanced way of doing it. So very interesting. And then, of course, many ideas were there related to rearranging the fins, having a different shape, optimization of the number of fins that you would have in the cooler, like 400 delivering the peak performance, then you're having more that's not adding any value, the things like that. Some water cooling suggestion and coolant based cooler suggestion as well. So those were interesting as well. However, I discussed with professor that if you use water cooling, then you would of course need to worry about the cooling the water itself once it becomes hot, right? So it's like you definitely don't want to transfer the problem from one place to other. You just need a kind of a comprehensive solution. Someone also made a suggestion that why don't you dump the water in the nearby pond, which is fine, and but that becomes very subjective, right? Depending on the uh, our machines go everywhere, including the testing that we do here. So if you don't have a pond nearby, and the whole logistics of dumping the hot water there might not be very practical. Some of you also made use of good tools that you have access to, like computational fluid dynamics, simulations, some MATLAB, some 3D modeling, and things like that. So that was very refreshing and interesting to see. But of course, in general, I appreciate everyone's effort and good job done. Uh, Many good ideas, and some ideas seem more practical than others when it comes to adapting them. Uh, and at the end of the day, I think in general, when you go to the industry, there are a few things which we always need to be mindful of, that the cost sensitivity, uh, like when you are in a business, you always have to make profit. Uh, so the solution has to be cost viable. In general, the industry trend is that you the less complex you are, better it is, unless you are delivering mm, excessive value, or unless the problem that you're solving is so hard that it cannot be done through easy or relatively less complex means, right? So that's something to keep in mind. And it can change based on the industry. For example, if you go to NASA or some of those companies where the idea, the importance, the idea is so huge that you're looking for some special material that can sustain extremely high and cold temperature when they are in the space, then maybe the cost is not a restrictive criteria for you, right? But in general, when you are in the business-oriented industries, you will have these restrictions. Few other things always when you design anything to keep in mind is how is the maintenance, what kind of maintenance would be needed, how difficult or easy it would be to do that, what kind of serviceability your product have, and what's the material availability in the regions where you are going to utilize your equipment. But yeah, these are some of the points that I could think of.
Great. Okay. So there's a comment in the chat. So just a student saying, thank you for your professional insight on this project. It was so enlightening seeing applications of heat transfer in an open-ended and real-world sense! Exclamation point. So just a thank you from a student. We've got there's at least half a dozen here. It looks like 7 students. So if there's anybody that wants to like make a comment or ask a question, and it doesn't specifically have to be about heat transfer, right? Like the goal here was to facilitate an interaction between UFMAE and Sandvik. So even if you guys have got questions just about industry or what it's like to be an engineer in professional practice, now is a good time to ask if you've got those questions. You can always type them in chat and I can read them too if you're reluctant to be recorded.
Did you have a particular favorite design? I don't know if you mentioned it in the beginning. I missed the beginning. But was there like a one that really stood out to you?
Okay. I think it's kind of hard for me to pick one, but there are a few that definitely are new to me. I wouldn't call them as far as the the idea is concerned. It might be just that since I never heard of that, that's why it might be more fascinating to me. Not necessarily that it was the greatest idea. But for example, the space change heat pipe, something unknown to me, that was definitely new. Uh, the idea of putting 4 fans in quadrants and having kind of looks very obvious, but definitely a very good design. Having turbulators inside the fan, another uh, maybe obvious thing, but it's a pretty good, suggestion, and something that's kind of already done or being done. Material change, people suggested that so we do buy coolers from different suppliers, and some do use copper in place of aluminum. The idea of running some tubes along the mast because of the availability of excessive area, I think that's a very interesting idea, really. Well, but the only problem I saw that there is like the heat dissipation numbers that we achieved doing that were not very uh, promising as such. So as long as you have to maintain both the systems, like a primary cooler and secondary benefit. That would be a bit, difficult for us. But some of these ideas of utilizing water for cooling and things like that, well, interesting ideas. Uh, but you have to think about the now cooling the water again. So another important one which I liked was the thinking about what to send to the cooler and when to send, when not to send, like flow diversion. That's interesting idea, and that is something we already kind of you do that, but you did not know that. So something to, and the cross flow, that having multiple manifolds and things like this. Some of this might be more, of course, theoretically back than more of experimental thing. So definitely, so I could see really that some groups put in more efforts than others, and a lot of students also quantified their uh, idea, like how much extra benefit you're delivering by this change, like a apple to apple comparison. In fact, I discussed with professors that for future it might be a good idea to put together a framework or a like a slide PowerPoint slide framework, that this is what exactly it should look like. Your understanding of the problem, your uh, current situation, your proposed solution, and then apple to apple comparison on the key numbers like heat dissipation, and what was it before and what will be with the new idea, of course, given the same constraints and things like that. And then whatever calculations and things like that that you created, where it will be, of course, it's part of appendix or something. So the I think the amount of data that we had, of course, maybe required a uh, more. You have to invest more time to completely go through and thoroughly understand it. But we did spend 4 or 5 hours to kind of go through it. So the least I can say that the efforts that you guys put in is we have gone through that. That was a long answer for your question, but
I appreciate it. Thank you.
There other, am I muted? No, I'm on. Okay. Are there other questions from students? If not, I have a question, but I want you guys to ask first if you've got questions. No. Okay. Well, then I'm gonna jump in and just ask. So something that I've been advocating for quite strongly, which I think our department finally is coming around and seeing the value of, but I would love your impression. So Sandvik is a uh, multinational, international company that has products out in the field all over the world. And something that we've been trying to do a lot more of in the department is give the students um, embedded in classes opportunities for international interactions. So we were not able to do it in the heat transfer class, but in fluids class last semester, which about half of the students enrolled in the heat transfer class were in my fluids class. Um, we did a virtual exchange with a university in Egypt, where the students in Egypt had lab kits, the American students had the same lab kits. And they essentially worked together to collect data and interpret data. They even wrote lab reports with a portion of the lab reports being in Arabic, so that the students had a chance to kind of write a lab report, at least with a part of it being in a foreign language. Um, does Sandvik or in general engineering companies place a premium or place value on students that have, especially engineering students that have international experience? Is that something that these guys would benefit from doing more of before they get out into the job market?
So one thing I can definitely add a value, or I can comment about, which will add a value, is that being aware of different cultures and being more inclusive in general is a way moving forward. Uh, if you talk about Sandvik, for example, we operate in pretty much all over the world, and we are originally a Swedish company. Uh, we are we have a very high presence in Sweden and Finland. We have a very high presence in United States and India, and in some in China as well. And of course, a huge market base pretty much all over the world, including Australia and sales offices and things like that. So if personally I have to talk about what I get exposed to, I get exposed to multiple nationalities on a daily basis. And you would see like a mini world population in here in our facility in Alachua. You have people from all over the world here, like South America and um, Australia and Finland and India and of course America and things like that. So that definitely mm, adds a value, and I think the ideas are ideas. There is nothing like you can only have good ideas, others cannot. So when it comes to, in general, uh, solving the problem, it doesn't matter really, right? Who is it coming from? But as far as mm, for example, if somebody is applying for a job, one of the question I like, we have not offshore, but what I don't know whatever you call it, but a design center in India where we work with them so closely on a daily basis, where on our design and engineering support side. But whenever we want something quick and something a lot of big work, which might require us to have I don't know 30 people in here, which we cannot probably afford it because of the high cost. You have to send it to India to get it done, and they're part of the Sandvik network. Like, they are Sandvik employees, so it's not like you're working with a third party contractor who doesn't know anything about your product. You they become your partner. And similarly, let's say our machines go to Australia. That region is one of our biggest customer base. So when I want to get a feedback on our machine, like how is the machine doing? Are you facing any problems? What are the challenges? And this is the solution we are planning. What do you think? Is it going to work out fine or no? Things like that. So we have a huge collaboration with them, and then that understanding, being respectful, and being open to ideas, doesn't matter where they're coming from, is definitely that definitely adds a lot of value and a lot of time. Uh, the attitude of people, the way you communicate, that may be a bit different uh, depending on who you talk to or which areas people you're talking to. So if you're a little bit sensitive to it, and I think you can have much healthier relationship with them. I have seen, if I talk to people who are up in the north in Canada versus people who are, let's say, in Florida, it's different. And people from Finland, totally different people, more kind of to the point, more direct, maybe more aggressive, things like that. So definitely huge value in collaboration with international community.
Thanks. Uh, more student questions if anyone has them. Otherwise, I've got more, but I'd rather have you guys ask. Nope. Okay. Okay. So next question from me then is, so these guys are, this is a 4,000 level class, right? So these are, by and large seniors, and most of them have, maybe 2 semesters left at the most. Um, One of the things that we're facing in higher ed and academia, is I'll just say it, transparently on the recording, a challenge with grade inflation, right? And this is impacting the students because their ability to differentiate themselves from maybe less well-performing peers is diminished as universities hand out more and more and more high grades. And so there's kind of an arms race among the students, at least I'm perceiving it, where they're trying to do co-curricular, extracurricular, project, all kinds of activities to kind of differentiate themselves in a way that's not tied to a GPA, because that's becoming a weaker differentiation now. So what can these students be doing that would get the attention of a decision maker, hiring manager, chief engineer at an engineering company, that would really set them apart and make them stronger candidates for employment?
I think that's a very good question, and personally, I have some preference over like what kind of people I enjoy working with or having in my team. I think I look for the aptitude and attitude that people have. The skill set is something which you can achieve or attain over time. So one of the challenge that I face when I interview people, particularly for technical roles, is that there are lots of good things on their resume, and the energy that they have spent is so much on the project or building side, building the prototype side, is that they somehow lose the connection with the actual theoretical learning that they should have had by the time they graduate from school. So example I would give you would be that if you get too much caught up with the idea of doing this or resolving this heating problem, and you come up with some idea, some good idea, weird idea, doesn't matter, but after the idea is there, if you're not able to justify that with your calculations and you do not understand your heat equations, or you do not understand your how failure theories work in structural engineering, what are the stress strain curve, and what is the true stress or engineering stress, what does Young's modulus mean to you, what is it really that you really need to understand. If you are a person who takes ANSYS or Abacus and you take a beam and you apply some loads here and there and you see the results, if that's a tool you're using, right? You need to understand the mechanics behind it. Like if you have a multi-axial loading, for example, on a plate, XYZ directions, and I ask this typical problem to the people who come for interview. And then, okay, you have a multi-axial loading, sigma X, sigma Y, sigma Z. How are you going to know is the plate going to fail? And the answers I get are sometimes very surprising to me, that Somebody says, I'll take the biggest one and, force upon area done. Somebody says, I will do FEA. So, but some of these basic problems or that basic strength of material understanding, your basically, in short, I'm trying to say that doing projects and doing whatever extracurricular you want to do, that's perfectly fine. But when you're studying, when you're enrolled in this heat transfer class, I think it's your obligation to understand the subject. You can get good grade, poor grade. That's another story, depending on how well you do in exam. But you really, really need to understand it. And the learning that you are getting when you are in the university and you're in contact with all the great academia people, like professors and things like that you're not going to get again in life. Once you go to industry, you you will not be having the greatest the smartest theoretically knowledgeable people. They will be more practically knowledgeable. So these opportunities you will lose, and you're paying for this, right? It's not free. So if I would be you, I would make use of this time and these learning opportunities, because when it comes to applying your knowledge, applying whatever you learned and doing practicals and doing uh, like seeing the product you're making, the whole life is there for you. That's what you want to do eventually when you come out of your school and join industry. But opportunities of going through those equations and reading those books and uh, questioning and why this is happening, and with this AI tools and internet era, there's so much you can learn. So, and if you're smart, believe me or not, you know it, you will excel in this industrial world, because then it's a matter of some of the things are like doing 3D modeling. There's no rocket science in that. You can do it. I know. Using abacus or answers, it's a tool. You can learn it. So Microsoft Excel, you can do things, but some of these core uh, learning that you're getting, it's like these are golden opportunities for you. So you make use of it. And then, of course, I'm not discouraging you from not being very practical. You should participate and try to use the book learnings and replicate them in real life. But don't just focus on the project aspect only. Also make use of this classroom sessions. So that's like a trend I'm seeing now. When I was in school, people were more into this of books, learnings, theoretical and all. But the newer trend, I see that nobody even wants to talk about. I ask people, what is your favorite subject that you learned in last whatever 4 years of your school? A lot of time they don't have a great answer, because they want me to focus on all the projects that they have listed. And when I talk about people have listed vibration issues, like I resolve vibration of this and that, but once you start getting into the depth of it, like what is it you really resolved, what vibration levels you diminished by, what was your solution, do you understand fast Fourier transformation, do you understand what is the time domain versus frequency domain, and what's really the logic behind it, then you realize then you were literally just the engineering is not about hit and trial, really, right? It should never be. It's about using analytical skills to foresee the problem beforehand, and then still doing some practicals to validate your data. That's engineering. Engineering is not about I'll make a beam, I'll put a load, let's see if it fails. If it doesn't fail, I'll make a fatter beam. It should never be that way. So, but that's I have very high expectation in general from my, I don't know, students or people I interview. Some people may be different.
All right, thanks. Uh, Again, a chance for students to ask questions. There's at least 6 of you guys in here, so I have more, but I want to make sure you guys have a chance to ask. Okay, well, I'll ask another one. So you mentioned AI, which is this is another thing that is taking a lot of academic brain cycles to try to wrap our minds around. Um, where do you see AI impacting your industry? Are you planning to implement any like AI enabled solutions? Do you use it for design? Do you use it for creative ideation? Like where does it show up in the engineering work that you do?
The pace at which I think the AI is impacting us is like mm, in mechanical world or in this heavy engineering equipment manufacturing world, I would say we the impact we see is always a little bit on the later side when something brand new comes of this sort in the market because of the fact that of course the software industry is more easily adaptable in their environment as opposed to what we do. So if you're in a core manufacturing and if you're in a little bit custom, designs and age-old conventional way of doing things, you definitely it's a bit harder to apply. But what I have seen in last, I would say, a few years, that the speed at which we're trying to make use of it is pretty impressive. In fact, uh, we are already using it for for example, I need to know some part number of some valve in our machine. We are designing or programming our chatbots that you just say, hey, I need a cylinder part number for so and so machine number and model. Give me that. So we are definitely making use of it. And I think as far as the replacing the jobs is concerned, which is what I'm kind of hearing in the industry, particularly on the software side. I think that's going to uh, be less severe for us because in our business, of course, there's still a big use of human interaction and purely. I think it's going to take a long time before the AI models are so smart that can give us perfect results that we are looking for. So it's more going to be in the assistance role than anything in our industry. Maybe in automotive or so, it may be a little more uh, adaptive because there is a mass production, there's a repetitiveness, so robots can do a lot of stuff. Whereas in our world, it's a little more custom make to order kind of situation. So that's where it becomes a bit tricky and harder. But the assistance that you get from it is definitely appreciable, and it, it's good. We are making good use of it already, and we hope to continue and make better use of it. Some of the things that we think are very repetitive, which a computer can do, we definitely have plans to use AI models for that to make ourselves more efficient.
All right, thanks. Okay, so one last appeal to the students. If anybody, we'll give you one more shot. If anybody has a question they want to ask or uh, comment they want to make, any sort of feedback, we'll give a moment to ask. Okay. All right. Going once, going twice. Sold. Okay. All right. So I think everybody's had a chance to ask everything that they wanted to ask, and I got a couple of questions in there. So I think if we're okay to wrap up, we could probably do that now. We originally scheduled an hour, but we don't need to spend the whole hour if students are done asking questions. Um, so I think we'll just wrap it there. So want to thank you. Chief Engineer Mishra, for the time that you spent both with coming up with the question and then sitting with me and watching the videos, and then this kind of follow-up session to give us your feedback and then answering questions that are sort of outside of the engineering design, but more practical kind of what's the industry like type questions. So we really appreciate. We know that you've got a lot of other things going on, and your time is valuable. So we really appreciate you spending that time with us these past 2 weeks. We do have a comment in chat, just another student just saying thank you with an exclamation point. So again, just deep appreciation, and I think we learned quite a bit in this first round through about what works well in these interactions, and so I hope we'll be able to continue doing this in the fall and spring. And in the fall and spring, it'll be in person, right? So we'll actually have a classroom full of students instead of a Zoom. So hope that we'll be able to bring you back and continue the collaboration.
Absolutely great. I think it was great working with you, Professor, and then I enjoyed my time in coming up with some, good problem, and I was happy to know that the students found it relevant and to their coursework, and they had lots of good questions in our previous sessions. Like I said, it was interesting to see all the videos and ideas that students came up with. And I think you have been a very good facilitator in all this, journey. So I truly appreciate all your effort, and I convey my best wishes to the whole team there, and good luck for the upcoming semesters. Thank you.
All right, we appreciate it. Thank you very much. So we'll wrap it up there. Let me hit the record stop button if I can find it. There it is.